All right, so as we look at section 3 for quadratic inequalities, we want to make this connection here just based off of the way a quadratic problem looks. Each of the way that it's illustrated means you got to do something a little bit different, okay, and the way the answers could be represented and so forth. So as we look at the first one, with f of x equal to ax squared plus bx plus c, that's a function. That's a quadratic function, which means that with this one right here, we're looking more at a graph, is what we look at as we go to illustrate the solutions to the problem. The second one here, a quadratic equation, is when we have it equal to 0. Some quadratic problem on the left-hand side equals 0. Or we solve and get everything on the same side and it equals 0 is another format. But that's an equation. And these, typically when we solve them, we're finding the x-intercepts. We're finding the zeros. The last one is a quadratic inequality. And this one is we're trying to find the range of answers that work for my problem here. So these are a range of answers. And so we can use actually the x-intercepts to help us determine which range of answers in the domain of x will allow me to be solutions to our problem. And that's what we're going to try to go through here, is just going to kind of connect them and what each one of them represent. So here are these problems here. They ask us to solve each equation and inequality. Use set builder notation or interval notation. I'll show you both again to write the solution sets to the inequality. So the first one is a quadratic equation because we got an equal sign. It's set equal to 0. So on this one, I want to think about factoring. So we have x minus 4 times x plus 3 equals, that's equal to 0. Then we use the ZPP to set each piece equal to 0 and solve for the solutions. So x minus 4 equals 0 and x plus 3 equals 0. So this tells me that x equals 4. That's one of my x-intercepts or solutions. And x equals negative 3. That's my other solution or intercept. Remember, they mean the same thing. And then, so how would I write that in set builder notation? The set of all, oops, sorry, it's a crazy little curly bracket there. The set of all x such that x equals negative 3, comma, and then 4, and close it. We wouldn't really write that one in interval notation. That's the set builder notation. You could list it with just the brackets and saying negative 3, comma 4. And that's how we list a set of numbers that are solutions. That doesn't mean in order. That doesn't mean like an interval at all. So either one of those would be fine. But again, there's no interval notation for that one that we could write. Now, we can use what we found there to help us do part B and part C. So on part B, it's asking us to figure out x squared minus x minus 12, this inequality here. And what it's saying is what they want us to do is what x values are able to be used so that the equation, the whole left side, the equation is less than 0. So if you're less than 0, that means you're a negative number. So in a nutshell, we're trying to figure out the y values are negative. The y values are negative. That's what we're looking for. We want to figure out which x values allow me to have a negative y answer as I look at the graph. So one thing you could do is you could graph this. You could go to and graph it. We know the x-intercepts we said are at negative 3, 1, 2, 3, and at positive 4. This parabola opens up, so that means our parabola would come down from the top left, crosses at -12, and somewhere there then comes back up. That's not exactly it. We probably want to do a graph on like the TI calculator or on Desmos or something like that. I think it's just shifted a smidge to the right. I have it too far to the left. But that at least it gives me an idea of, okay, which x values are being used so that my answer or my graph is below the x-axis, and or that's where my y's are negative. My y values are negative means graph is below x-axis. Below x-axis. So with that in mind, we take a look here and we say, well, here we're below the x-axis. Well, that happens to be between here, -3, and here, 4. So we would say in interval notation, -3 to 4 is when I'm below the x-axis. Interval, if I was going to do it in set builder notation, the set of all x such that -3 is less than x, which is less than 4. We would not use an equal to bar on these really, just because when I'm at -3 and I'm at +4, I'm actually 0 for an answer. So technically that 0 has no positive or negative value, so we would leave the equal to bars off of that one. The third one, part C is basically change the inequality around and say, you know what, when is the equation, when is this quadratic equation, this function or whatever, this quadratic thingy, when is it greater than 0? So when is the graph above 0? So when is graph above 0? So when is the graph, the y values positive? Here we're looking for the y values to be positive. So as we look at it, well, here is the x-axis, that line right there. So that's this zone right here. That's where I'm above, and also over here. Now that's 2 sections worth of the graph. So we'd want to go through and use our, I'm going to do interval notation. We're going to start from the left, from -infinity to -3. I am above the x-axis is where I'm at. And then union the other x-intercept 4 to +infinity. And so those are the 2 parts on when the x value is being used that gives me a positive y answer, because that's when the graph is above the y-axis. Again, a lot easier to graph it and then look to see when am I above the x-axis, when am I below the x-axis. I'll show you an alternate method on problem number 8, to where if you don't have access to a graphing calculator to where you can graph it, how can we use the information they give us after we find the x-intercepts? How can I go about determining when I'm above and when I'm below? So I'm going to show you what's called the number line technique. So the first one, we got to solve for the x-intercepts. These gives us our x-intercepts or our solutions. So let's see, that factors into an x minus 6 times an x minus 2. Set each piece equal to 0, x minus 6 equals 0, x minus 2 equals 0. Using the ZPP, that gives me x equals 6, x equals 2. So those are my 2 solutions. Those are my x-intercepts, 2 and 6. So now, again, I don't have a graphing calculator handy, so what we do is we use what's called the number line technique. So what we do is we draw a number line. We indicate where our numbers are, so 2 and 6, my 2 intercepts that I found. And now what I do is I test values. I do some test values. I pick numbers, a number less than 2, so I'm going to pick 0. I'm going to pick a number that's between 2 and 6, so I'm going to choose 4. And then I'm going to choose a number that's bigger than 6, so I'm going to use 8. Is what I choose. I would say always use 0 in one of the intervals, because that makes the math go a lot easier. So now, as we go through, we're going to put 0 into our problem, and we're going to decide, okay, is my answer less than 0? Is it going to, when I put 0 in there, will I get a negative answer? So for part B, as we're looking at it, 0 squared minus 8 times 0 plus 12. Are you less than 0? That's 0 minus 0 plus 12 less than 0. No, 12 is not less than 0. No. So that tells me that actually during this part of the problem, it is positive. I get a positive answer when I choose a number. In that interval. Let's go ahead and test the 4. So now we're going to say, okay, is 4 squared minus 8 times 4 plus 12, are you less than 0? So are you a negative answer? So is 16 minus 32 plus 12 less than 0? 16 minus 32 is a negative 16, plus 12 is a negative 4. Hey, negative 4 is less than 0, so then during this zone I am negative. And I'm going to go ahead and do the last one because we'll be able to grab not only the answer for part B here, but also part C here when we do this. So now I try the 8, and we say 8 squared minus 8 times 8 plus 12. Are you positive? Are you greater than 0? Oh, sorry, I looked at the wrong thing. My bad. Are we less than 0 is what we're trying to test here. Are we less than 0? So are you a negative answer? Well, that'd be 64 minus 64 plus 12. No, actually, this is 12 is less than 0, so this is not negative. This ends up being positive. So those let us know that they weren't solution zones for our problem. So our only solution zone for our problem for part B would technically be between 2 and 6. For now, we've already answered part C. When do I get positive answers for Y? Well, when do we have the words positive written down? Well, technically from negative infinity to 2, union of 6 to infinity. Again, with the quadratic functions, or quadratic problems, this should be fairly generic, the quadratic problems, I'm going to have, usually one negative zone and 2 positive zones, or I would have one positive zone and 2 negative zones. That would come about if the quadratic problem opened down and went across the x-axis that way. All right. Again, here's some general, just little guidelines to look at. That you can always rewrite those with any one of the symbols. We can apply this stuff to. Try to find the x-intercepts. You can graph it if you don't want to graph it. If you can factor easily, you can find them that way. But again, graphing makes it a little bit easier to find the x-intercepts. Let's use, for example, the last problem. Let's say we wanted to find the x-intercept and you struggle with your factoring techniques and you're allowed to use a calculator. Okay, so I'm going to get out here, hopefully to the TI calculator app. Give it a chance. There we go. Launch it. And I'm going to go in there and I'm going to go into y equals, and I'm going to type in the equation, x squared minus 8x plus 12. There's my quadratic problem. I'm going to tell it to graph it. And I notice there's 2 spots that it touches. Now I have the option that if I want to look at the table, say second graph, and I look to see when is 0 in the y column. Well, I see 2, 0, and then I also see 6, 0. So those would be my 2 answers. Again, if I wanted to, I could get it to, when it's a more complex problem where it might be a decimal x-intercept, we can do second trace, and option number 2, find me the zeros. And now what we do is we move a cursor to go on the left side of where we see an x-intercept, and I press enter, that's the left side. Go to the right side of where I think an x-intercept is, that's on the right side. Hit, and then say, they want to guess it? Yeah, I want you to guess it. And so it gives me 2, 0. And then I repeat the same thing for the other side. I go second trace. So I want to find the x-intercept as 0. So now I'm going to go to the left side of where I see the next x-intercept. Press enter. Go to the right side of that point. Hit enter. And then, yes, I want it to guess it. And it tells me 6, 0 for the other one. So, again, if you can remember those features, then we use those features. Just not graph it. See where it touches the x-axis. And then you can always, if it factors nicely, you can use the factoring method to help you figure that out. And again, as we look at it, this picture, between 2 and 6, we see that the graph is below the x-axis. And if we notice back to our little number line, we said that, hey, between 2 and 6, my y values were negative. Well, that means that your graph is below the x-axis there. If you're positive, that means you're above the x-axis, and that's what we notice about to the right of the blinking dot. We see that it's that case and so forth. So again, hope that helps. Again, this is just a lot of playing around, and we got some word problems with this that we're going to do here in a moment. But we're going to finish up with one more set of problems where they actually give us the pictures and they ask us to determine when, these little statements here. So they say the graph of f of x is as follows. These parabolas solve the inequality. So this top one just says, hey, when, again, this is just asking me what x values are used to make the graph below x-axis. So when is that graph below the x-axis? Well, for me, I can tell right here, it looks like this is when I'm below the x-axis. So it's between this x value and this x value. Well, that would mean from 1, 2, 3, -3 to +2, that's when I'm below the x-axis. Part B says, when am I greater than or equal to 0? So when am I above the x-axis or 0? Because it does say equal to. Okay, so it does say equal to. So that means here it's equal, there it's equal, and then I'm above in these zones right here. So this one we would say for part B, sorry about that, we would say from -infinity to -3, and since it said equal to 0, I get to put a square bracket on it. And then union square bracket 2 to +infinity. And then 24 is doing the same thing. Notice there's no equal to bar in the problems on 24, so that means they're all going to involve parentheses. There's going to be no brackets. So when is the graph above 0? So when is it above the x-axis is part A. So I'm above the x-axis here. So from -1 to 4, I am above. So that's A. And then part B, when am I below? Well, I'm below, and I'm below over here. So we would say for part B, from -infinity to -1, we get to reuse those numbers up above, union 4 to infinity. So again, you're going to get 2 of one zone and 1 of the other zone. So they're going to be either 2 positives and 1 negative, or 1 positive and 2 negatives as you're going to indicate. And they're all based off of the x values as you write the answers. And you're just deciding when are you above or when are you below the x-axis.